Hello student. So in this beam we have given at point A there is hinge support, from point B to point D up to 2 meter span there is a UDL given of intensity 5 kilonewton per meters. At point C there is a point load given of 30 kilonewtons. Then at point E the point load is of 14 kilonewtons. Then from point F to point I, the span is of 3 meters and a UDL is given of intensity 10 kilonewton per meters. And at point J, there is a roller support. So each span is of 1 meter. So overall we can consider as 9 meter span. So we have to find out shear force as well as bending moment at each 1 meter span. So first of all we have to find out support reactions. Now to find out support reactions, first of all you can take moment at any end point either A or J equals to 0. I am taking moment at point A equals to 0. Now I am assuming convention as clockwise moment positive. One may take anti-clockwise also positive. Now first of all at point A, if I am considering this 30 kilonewton force is going in clockwise direction, so I am taking this 30 kilonewton as positive. So 30 multiplied with this 2 meters, so that is 30 into 2. Then this UDL, again it is going in clockwise direction, so 5 for UDL, what we do, 5 multiplied with the span of the UDL, that is 1 plus 1, 2 meters. So 5 into 2. Now if the UDL is not extended from point B to point A, so what you have to consider is, first of all, for the other length, first of all 5 into 2 is the length of the span, and for the centroidal distance in bracket we have to put 1 plus 1 2 divided by 2, that is half of this distance, so 2 by 2, plus from point B to point A the distance is 1 meter, so 2 by 2 plus 1, plus this 14 kilonewton force is also going in clockwise direction, so we should take it as positive, and the distance is 1, 2, 3 and 4 meters, so 14 multiplied with force. Then this UDL is of span 3 meters and intensity 10, so 10 into 3 into, again this UDL is also not extended up to point A, so in bracket we have to take half of the overall span of the UDL, that is 3, so 3 by 2 plus the remaining distance, that is 1, 2, 3, 4 and 5, so 3 by 2 plus 5. Then this RJ, reaction at J is going in anti-clockwise direction, so RJ multiplied with this total 9 meter distance, so RJ into 9 equals to 0. Okay, so from this when we put it in calculator we'll get RJ equals to 36.78 kilonewton. As because it is positive, so we have to consider as upward direction assumed correct. Next, to find out RA we will take summation Fy, that is addition of all vertical forces, that is upward as well as downward, equal to 0. I am assuming convention as upward force positive. So I have this RA, which value I have to find out. Then 30 is downward, so I am taking minus this UDL 5 into this distance 2 is downward, so minus 5 into 2. Then this point load 14 again in downward, so minus 14. Then this 10 UDL is downward and the span is 3, so minus 10 into 3, and this RJ is upward, so plus RJ equals to 0. From here we can get value of RA equals to 47.22 kilonewton. As because I got the answer in positive, so I have to write down the assumed direction, that is upward, of this RA is also correct. Now we have to find out first of all shear forces at each point. So at point A the shear force will be the support reaction at A, which is 47.22. Now from point A to point B there is no load acting, so we have to draw a straight line. Now from point B, if I have to calculate shear force at C, so what I'll do, from because at point C there is point load also acting, so we have to consider shear force at C left, and then we will do shear force at C right. So first of all, to do shear force at C left, this 47.22 we have written here minus this UDL 5 multiplied with the distance 1, because we have to calculate up to this much distance up to point C. Okay, so minus 5 into 1, which is 7.22 kilonewton. Sorry, my mistake. Shear force at C is equal to 47.22 minus 5 into 1, that is 42.22. See, this is 47.22 minus 5 into 1. 47.22 minus 5 into 1, that is 42.22 kilonewtons. Then as soon as I cross this point, we come across this 30 kilonewton load which is downwards, so that from that 42.22 answer which we got here, we have to copy and subtract 30. So we get it as 12.22 kilonewtons. Now once I reach point D, now this half UDL is remaining of 5 into 1 meter length. So 12.22 minus 5, that is this much UDL, half UDL now, 5 into 1. So 12.22 minus 5 into 1, that is 7.22 kilonewton. Now again here at point E there is a shear force acting. So at point E 14 kilonewton. So before point E, whatever the load is there up to point D, we have to copy for shear force at E left. So shear force at E left will copy this value, and when I am writing shear force at E right, I have to subtract 14, which is this value, and I am getting as 6.78. As soon as I am reaching this point 6.78, we have to go downwards. So from 47.22 we reached here same, then we subtracted this UDL, we got 42.22. At the same point we had this 30, so we got 12.22. From here we subtracted half UDL, that is of this much length, and we got 7.22. From this till point E, no load before reaching point E, so 7.22 as we found out. Then from point E we have this 14 kilonewton load, so we went down because it was minus 6.78, and from point E to F there is no load acting, so 6.78 we will copy, minus 6.78. So shear force at F will be minus 6.78 kilonewtons. Now we have to calculate shear force at each point. So shear force at G, H and I. Okay, first of all shear force at G. So this much distance only have to consider, that is the UDL of 10 intensity and 1 meter span. So shear force at G will be this minus 6.78 minus 10 into this much distance will be for up to point G 1 meter. So minus 10 into 1, I would get minus 16.78. When I am reaching next, again I will subtract this 10 into 1 next slot. So it's minus 16.78, that is previous answer, minus 10 into 1 I would get 26.7F. Now when I reach this point, again this 10 kilometer per meter UDL multiplied with 1 meter span. So minus 16.78 minus 10 into 1, we would get it as minus 26.78. Okay, and then when I am reaching this point I, this minus 26.78 minus 10 into 1, I would get minus 36.78. Now as soon as I leave this point, before reaching point J there is no another load acting. So whatever the load we had, shear force we had at point I, same load I have to copy at J. So minus 36.78 as it is. Now as soon as I reach this point J, before reaching point J we would copy the same load, that is minus 36.78, and as soon as I reach point J, minus 36.78, and this reaction at J plus 36.78 will neutralize it and give you value at 0. Then that means it is correct. Now to do bending moment calculation, wherever we have this UDL, we have to draw parabolic, that is this much span and this much span. So while drawing parabolic nature, we'll just hatch it and just show P, that shows you have drawn parabolic curvature. Now to find out bending moment at A and J, as because the beam is simply supported, so end points will have moment equals to 0. Now to calculate moment at B, this 47.22 multiplied this shear force at A or reaction at A multiplied with 1 meter would give you 47.22. I have written here kilonewton meters. Bending moment at C when we are calculating, so this 47.22 multiplied with the distance up to C, the distance is 2 meters. So I have written here for C 47.22 into 2 minus for this UDL 5, up to this much span you have to consider, right? So the intensity is 5, so minus 5 into UDL, it is 1 into 1 square by 2. So 5 into 1 square by 2, 5 into 1 into 1 by 2, that means 5 into 1 square by 2. We would get value as 91.94. Now for bending moment at D, okay, so again this force 47.22 multiplied with 3 meter distance, then this UDL, that is 5 into 2 into 2 by 2. See, 47.22 into 3 minus 5 into 2 square by 2 minus this 30 load going anti-clockwise, so minus 30 into distance is 1, so minus 30 into 1 we would get it as 101.66 kilonewton meters. Okay, so 47.22, then from here onwards we have to draw, as because UDL is starting from point B, parabolic for 101.66, again parabolic. Now when we have to find out at point E, so it is 47.22 multiplied with this 4 meter distance, then minus this 5 into the span is 2, so 5 into 2, but this UDL is not extended up to point E, so 2 by 2 span by 2 we are reaching till point D. From D to E the distance is 1, so plus 1 minus this 30, and the distance between point E and this 30 is 2, so minus 30 into 2 we would get it as 108.88 kilonewton meters. Then to find out at point F, now, instead of going from here, we would find out that from other side we get less number of forces, so I'll go from this side. So from RJ I have 36.78, so 36.78, and up to point F I have 4 meter distance, so 36.78 into 4 minus this UDL multiplied with 3 meter distance, so 10 into 3 into distance divided by 2, that is 3 by 2, I would get it as 102.12. To find out at G, same way, 36.78 multiplied with now 3 meter distance, so 36.78 into 3 minus, now this UDL is up to this 2 meter only, so 10 into 2 square by 2, that is 90.34. Then to find out at point H, so 36.78 and up to point H is now 2 meter distance, and then the UDL will have only 1 meter distance, so 1 square divided by 2 we would get it as 68.56 kilonewton meters. And then comes last point, that is BMI, so only one force, that is 36.78 multiplied with distance as 1, I would get it as 36.78 kilonewton meters. For the same, I'll send you this one PDF or the photograph of this solved example also. Thank you.